Okay, yes, thanks everyone. So, so Dale and the Keystone team talked about the Keystone open source secure enclave. It's the first end-to-end open source framework for building customizable teas. And overall, as we know, building a truly trustworthy secure enclave, actually there's a lot of challenges. And it really needs a whole community effort. So now I want to talk a little bit about a new effort that we are helping the community to start on Trustworthy Secure Enclave Alliance. Again, Dale has already mentioned Secure Enclave helps provide an isolated execution environment to essentially enable the integrity and confidentiality for computation inside the enclave. And one of the key properties and capabilities of TEAS is that it can significantly reduce the trusted computing base. So for example, operating systems is at the order of millions of lines of code, and even hypervisors is at the order of hundreds of thousands of lines of code, where Dale has mentioned that, for example, for the Keystone Secure Enclave, the trusted computing base is about 10,000 lines of code. And as we have already discussed, Secure Enclave essentially can really serve as a cornerstone security primitive, given the strong security capabilities that it can provide. It can help authenticate itself, the device, can authenticate the software, can guarantee the integrity and confidentiality of the execution, and essentially can simulate a trusted third party for secure computation. And the Secure Enclave essentially can provide a foundational platform for building new security applications that couldn't be built otherwise for the same practical performance. It has wide-ranging applications in different domains for building secure IoT devices, even to enable the security of essentially the source of the data, and for confidential computing in the cloud, and for doing secure computing across multiple parties, and for enabling decentralized applications. And also, one important note is that while even my own research group and other researchers in the community has been working on crypto-based techniques such as homomorphic encryption, multi-party computation, and zero-knowledge proofs, and so on, one significant advantage of the secure hardware-based approaches comparing to crypto-based approaches is the practical performance that oftentimes, essentially, it can achieve close to native performance. And given the importance of secure hardware, over the years, different hardware manufacturers have all designed and developed its own different versions of Secure Enclave. However, all the solutions today on the market are all closed source. And this is one of the key motivations also for the Keystone team to start developing this fully end-to-end open source Secure Enclave. And still, there are many challenges remaining in secure hardware. How secure can it be under what threat models? What would you entrust with secure hardware? Your Bitcoin keys, your financial data, your health data? And the ultimate question is, how can we create a truly trustworthy secure enclave that can serve as a cornerstone security primitive? If we can do this, this can really enable widely deployed, it can really enable secure systems to be built on top that are widely deployed. And this can really help the whole community to usher into a new era for secure computing. So what is the path to building a truly trustworthy secure enclave? We believe that there are several important steps and components. One is open source design. With the open source design, it provides the transparency that's needed to have the whole community to come together to be able to analyze and verify the security and correctness of the secure enclave, and hence achieve the high assurance that's needed. And also, an open source design implementation can really help build a whole community. And also, Dale already mentioned in his talk, to really have a widely applicable secure enclave, essentially we need to provide flexibility and extensibility for the design in order to be able to support diverse use cases. And also, ideally, we would like to be able to provide formal verification to really provide provable guarantees for the security and correctness of the design implementation. And finally, we need to have secure supply chain management to ensure the security of the hardware manufacturing process. So the Keystone project has aimed to address several factors of the list that I mentioned here. Keystone is open source, and as Dale has already mentioned, it's really designed to enable flexibility and extensibility to make it really easy to develop different types of secure enclave that's customized for different use cases. And also, we have ongoing formal verification efforts, and also we hope, and also there's already a lot of interest from the formal verification community to help together to work on formal verification of the secure enclave. But still, as I mentioned, these are just about the design and implementation of the secure enclave. There's also the supply chain management, and also overall, there are other aspects to really ensure the security, the full life cycle of the security of a truly trustworthy secure enclave. I have one prediction, and I hope that this is the world that we are moving into, is that in 10 years, most chips will have secure enclave capabilities. Given either it's just a desktop, laptop, or IoT devices, or even AI chips. I do hope that in 10 years, this is the world that we will see, that most chips will have secure enclave capabilities. I think this will really lead the whole community and the whole world into a new era where, again, as we already discussed about the strong capabilities that secure enclave can enable, if we are in this world, then I think people can envision the type of new systems and applications and the security and privacy capabilities that the world can offer. Towards that goal, we are starting a Trustworthy Secure Enclave Alliance, and David will talk more about it.
Thanks. So yes, obviously, if we're talking about putting enclaves in approximately everything, there's a lot of interesting decisions to be made there, and we don't want that to be made kind of in a fragmentary way. So there's a number of principles here that the Alliance is getting started under. The first is open design. Dawn has talked a lot about why we think kind of open design is the right avenue here. The second is decentralized trust. I'm going to talk a little bit about what that means in our context. And the third is end-to-end lifecycle security. And this is something that we're going to have to kind of figure out together. So as far as decentralized trust goes, there's kind of three components to it that we've been talking about internally. And the first is one that we have good answers for, which is how do we talk about publishing and certifying public keys for enclaves in a decentralized way? So you don't need to trust that just the manufacturer is saying that this is the key that has been programmed into this device. So in this model, the chips are going to generate their own keys internally. These are not going to be programmed by the manufacturer at the time of manufacture. And at that point, the manufacturer will engage in an attestation process with that chip in their physical possession. This is a process that will require physical possession. And they'll be able to generate a certificate that it indicates that, yes, we believe that this chip is a genuine chip and it has the following certificate. But also will allow other Alliance members who get physical control of the machine at any time to generate their own certificates through a physical interaction with the chip. At this point, we now have a variety of independent attestations and proofs that this is the key that was on this chip and it was generated by this chip. So this makes sense to us. There are, however, a number of open questions about then how you manage these certificates and how you make trust decisions about them. The first is attestation services. So we expect that members of the Alliance would run their own set of attestation servers. But how we agree between the different servers and how we deconflict between them is a question that we're kind of hoping that the Alliance will sit down and talk through. The third part of this is maintaining revocation lists. And if you've worked with CAs at all, you understand that this can be a challenging problem. If we query a certificate against a number of these different services and one of them says revoked and the others do not, do we trust that one revocation? Are we performing some kind of distributed systems consensus protocol? Or as Don points out, are we solving this with a blockchain? So if you want to help answer these questions, we're looking for people to join the Trustworthy Secure Enclaves Alliance. We already have HTC as well as a number of other partners who are joining, and we're going to be talking to a wide variety of entities going forward. And with that, we can take, I think, one question maybe, but then we'll have to move on. Thank you.
Are you expecting financial contributions from members?
Yes. Yes, we are. I think we're going to have to go there. You're welcome to come talk to Dawn or me afterwards to talk about the Alliance. Thank you.